Hello once again, our most developed student. My name is Confident and welcome to our 24-minute lesson. This is the ultimate guide in maths, science, career guidance, as well as a sneak peek into my personal experiences. This is a channel designed with you in mind. Let us dive into today's lesson. In this series of videos, which I call the Ultimate Guide to Organic Chemistry, we are continuing with our lesson on the IUPAC naming of haloalkanes, sometimes referred to as alkyl halides. So this is a very important topic because most of the questions sometimes they come from this section where you get this haloalkanes. Now haloalkanes, I think you remember, these are halogens in group 7, and when we're talking about them, we're talking about the fluorine, we're talking about the chlorine or the chloride, the bromide, and the iodine. So mostly is 4, and they are referred to as X. So whenever you're looking at the general the functional group of this one, remember it's C, and then you have got H, and then you've got H, and you have got X. See, this particular X is the part which then becomes what we're talking about here to say it can be fluorine, chloride, bromide, and fluoride, chloride, bromide, and iodide or iodine. Now, when we are looking at them as substituents, or when you're looking at these as as substituents, you call fluoro here, and this one becomes chloro, and this one becomes bromo, and this one becomes iodo. Don't forget fluoro, chloro, bromo, iodo. Now when you are naming these in an organic molecule, you have to follow, because all of them, they are equally they are equal to each other. Let's say there are 2 of them in an organic molecule. You follow the alphabetical order. You see, you follow the alphabetical order, meaning most of the time B is going to be number 1, bromo, and then number 2 is chloro, that is C, and then B, C, D, E, F. F will follow. F is number 3, F, A, B, C, D, F, G, H, I is number 4. But now we can add some bit of extra kind of in here to say you have got the alkyl groups that you can mix in here, and our main alkyl groups is methyl and ethyl. So now when you've got these also in an organic molecule, now it gets to be a bit complicated now, because they are all valid the same, like nothing takes precedence over the other. You just have to follow the alphabetical order. So you start with bromo, B, and then A, B, C, then follow with chloro, C, D, E, you follow with ethyl. So it's A, B, C, D, E, F, you follow with fluoro, F, G, H, I, you have got iodo, and then after that you have got methyl. You see this order, so you are moving in this order, guys. Don't forget that. I was just wanted to lay this information to say follow the alphabetical order in events that they are all appearing in an organic molecule. So now let's look at this. When you start with this IUPAC naming of alkyl halides, you must understand that there are 3 types of haloalkanes. There is the primary haloalkane, which is 1 degree, the first degree. Secondary is 2nd degree, and tertiary is 3rd degree. It's 3 degree. You know, when you do it at varsity, they will be talking about the degrees. But for now, just know that it's primary, secondary, and tertiary. Now, a primary haloalkane is the standard, the basic one. Let me make an example. If it's like this, you have got RX, where R is it's an organic part of the molecule. It's an alkyl in a way. The R here represents the alkyl group. For example, if I say methane. Remember, methane comes from, if I've got methane, now methane becomes methyl, which is what? Which is CH3. Then if I put X here like this becomes a primary one. So X can be now, for example, Cl. If I draw the structure of that, this is what I'm talking about. So you have got Cl, H, H, H. This is what? This is chloromethane. Doesn't matter, you can name as many as you have. Now let's talk about, for example, let's say in group 6 is hexane. So hexane, I just want to show you how to, hexane becomes hexyl. Why? Because it's hexyl alkyl group. So the hexyl group now has got CH3, CH2, CH2, CH2. So it's CH3, CH2, 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 CH2. How many are these? 1, 2, 3, 4, 5. And then CH2. Instead of CH3 at the end, it becomes CH2 because an alkyl has got 1 hydrogen missing. Then you can put the X there. So now in this structure, we can come up with the one with hexane. You can say 1, 2, 3, 4, 5, 6. Then I put here maybe Br. So it is at the end of the molecule. So at the end of the molecule, put the hydrogens there. I'm just trying to be a bit faster here. You know, when you put hydrogens here, what will be the name of this one? The name of this one is bromohexane. This is bromohexane. It's primary. Why? Because the Br is at the end. So again, guys, don't be fooled. If I can draw the structure, for example, let's say bromobutane. Bromobutane, I can even draw it like this. 1, 2, 3. Let's say bromopropane, because of my space. You see, I can start with bromide here. It's still bromopropane. This is still the same as doing this, then putting the Br at the end. These are the same structures. If these were hydrogens, they are the same. Whether you start with bromo, you end with bromo, it's the same as long as it is at the end of a carbon chain. Remember, when I'm naming, I'll start by saying 1, 2, 3, 4, and so on. But when I'm naming on this one, I start here as carbon 1, and here I start this as carbon 1. I'll go this direction, here I go this direction. Alright, so what do you call that? We call this the primary. So the key part of the primary is that you have your R and you have your halogen. Now look at this other one, secondary. In the secondary, it's a bit different. Now you have your R, then you have got your C, and you have got another R, and you have got X. This becomes the secondary. Let's make an example. I can have here, for example, I can have C, and then I can have here CH3. I can have here CH3, it can be the same, and then I can have here H, and then I can have here F, like this. And then I ask you, what is the name or what is the structure here? If I can draw it the proper way, you'll be having this C, C, C. So okay, actually it's C, 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 yes. So here I will have this. So here again I have this. Now look at the important part. Now you have got hydrogen here, and that's where the X is. That's where the most important part is. Now if I can take you back a little bit back, in the other one, for example, if it was propane one, it would be like this, where the bromo was here, it was like this, bromopropane. See, look at it, it's at the end. Or let me make it X. X is at the end. X is at the end. So when this X moves from here, it goes here, where you remove this one, which goes this other side. You see, now it's in the middle now. not in the middle, but is inside now. What do you call that? You call that the secondary. You see that? But the aim is to ensure that the X, it doesn't matter, it doesn't have to be as such in the center, because I can even draw the structure like this. It's still secondary. I can continue with a C and do that. You see that it's no longer now in the center now. It's still, as long as it is inside. Now when I'm talking about this structure, for example, it will be fluoro, so you can see that it's what will be the name of this structure here. I will call it carbon 1. Now the naming starts from here, this direction. It's carbon 1, carbon 2, carbon 3. If it was this, is carbon 4. So it's 2-fluorobutane. Well, in small letters after all. F is small, B is small, so it's 2-fluorobutane. Do you understand what I'm saying? While it's inside the molecule. Now let's come with the tertiary. Now the tertiary is like this one, whereby you have got your carbon here. I've got my first R. Okay, let's start here. I've got my first R, my second R, my third R with an H. It's more like this. So if I can draw the tertiary one, it will be more like I'm having this. Just want to show you. It's like I've got, let's say in here I've got CH3, I've got here, and then I've got CH3, and then here I've got my halogen, and then here I've got my CH3. Now look at this. I've got that, I've got that, I've got that, but I can change these the way I want to change them. I can change this to become maybe CH3 CH2. See, then CH3 doesn't matter how I name it, but look at it, it's surrounded by 3 alkyl. This is the first alkyl, this is the second alkyl, and this is the third alkyl. That's why this you can call it R, this R1, this R2. I hope you're seeing what's happening there. So if I can name this, let's say for instance my X here was chloro. So this one will be, in a way, this is carbon 1, carbon 2, carbon 3, carbon 4. Right. So if you look at this carbon 1, carbon 2, carbon 3, carbon 4, it comes from what? From butane. And there is a what? In carbon number 3, there is 3-methyl, because this now becomes a branch. See? 3-methyl. Okay, there is a branch, and this one also is 3-chloro. So which means, which one comes first? C and M is C. So it's 3 first, chloro, then hyphen, 3-methyl, and then butane. Did you see how I come up with? Let me repeat again. Maybe I was too fast here. Look at this. I look at carbon number 3. There is a branch, and there are 2 branches, the methyl and the chloro. Alright. Now, which one comes first? It's C before M. So it's 3-chloro, and then hyphen 3-methyl. You see this? And then it's what? 1, 2, 3, 4. It's butane. See, there is a branch. So if you look at the flow of things, this one was just inside. There was 2. Now when the flow of things here, let me look at this just to show you. This is how they flow. So if you look at the F that you did here, so you will have C, and then I'll have X, and then here I'll have H, and then I want to show you I've got R, and then I've got R1. You see that? Then when I come here on the secondary, on the tertiary, I've got not only that, but I get to have similarly my C, my X. Now that's where things change now, whereby here I've got my R, here is my R1, here is my R for 2. See that there are 2 there. And then in the beginning I showed you to say it's only R. I can actually convert this to say I've got C, then I've got R, here I've got H, here I've got X, and here I've got H. So it's got only one R with 2 H. Here I've got 2 R with 1 H. Here I've got 3 R, no H. I think that this is primary, secondary, and tertiary. Are you with me? Now looking at this, let's look at the IUPAC naming now. I hope I've laid enough foundation for you. Now let's look at the IUPAC naming. Now you know how to name these. The aim is to look at the longest chain first, and your primary, or the one, what do we call this? We call it the functional group here. Functional group. The functional group is what makes it behave the way it behaves to belong to a homologous series is this guy here, chloro, not the methyl, but the chloro. So which means it takes priority. If I number it in this direction, it will be carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6. If I number it backwards, it's carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6. You can see that chloro, we choose the smallest numbering, which is carbon number 3, and which means I'm moving from left to right. That's the right way. Are you with me? So if I have to number it from left to right, you can see that carbon number 3 is the right way. So it will be what? And then I've got also a branch. Remember, this is my longest chain, and you can see there is a branch, this branch. And what do you call this branch? Methyl. So now I can name this molecule as what? Its alphabetical order is 3 chloro hyphen, and then it's carbon number 4 there. It's 4 hyphen methyl, and then how many carbons? 1, 2, 3, 4, 5, 6 in the parent chain, and it's hexane. See that? That's how you name that. Move on to the next one. What will you name this one? Now again, as I said, start from left to right. If you move this direction, this is carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. If I move this direction again, it's carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. And Br is what makes us take priority. So you can see that Br is in carbon number 3. So I'm going to write it both so that I can show you very, very important section here. Look at this now. If I'm naming it from left to right, let's name it. It's in carbon 3, so it's 3, 3. See, there are 2 Br hyphen dibromo, because there are 2 of them, dibromo, and then hyphen in carbon number 4. Now that's where I get this methyl. You see, I've got a methyl here. It's in carbon number 4 if I'm using my naming from left to right. It's 4 hyphen, always maintain the naming, 4 methyl what? It's 1, 2, 3, 4, 5. 4 methyl, I know I don't have space now, pentane. Should have written it as one word, but don't forget you don't space. Methyl pentane is one word. Look, that was from right to left. Let's move from left. Okay, let me do this. Write it down here. From right to left. This was from left to right. So from right to left. So which means we're moving in this direction. Let's do it again. It will be 3, 3 hyphen dibromo, and then look at the methyl is number 2, so hyphen 2 hyphen methyl what? Hexane 6, right? Now this is where you need to be sensitive. You see 3, 3, 3, which means dibromo, the one that we are actually that is actually making us choose the functional group there is bromo. So you see that it's not changing between the two. But look at the methyl. This is 4 and this is 2. And in IUPAC naming, we always follow the lowest naming from the end. So which one will you take? Which one is bigger, 4 and 2? 2 is the smallest. So the right one is that one, because this one gives us more numbering. It says 4 methyl is higher numbering, but the other one gives us list numbering, which is what? 2-methyl. So guys, the answer is here. I hope you are able to kind of distinguish these scenarios as I'm bringing them to you. Next one says question here. I think this question was previous. It's a previous question that I did and then sorry about that, but let's look at this one. This is the last one. It says more examples. It says write the IUPAC name of the following compound. Let's look at this compound. As I said, what takes precedence is your functional group, and the list number from the end is one that you take priority. Okay, so you can see that I've got a BR here and a BR here and there, so it forces me to use this as my longest chain. I can't go up. I can't use this one go up like that because I'm gonna sideline that. Are you with me? So we have to go straight. Now look at this. If we move, what I'll always advise, do the left to right and do the right to left. So let's say we are moving in this direction. So this is my carbon number 1, carbon 2, carbon 3, carbon 4, 5, 6, 7. What will be the numbering here? And then, oh, by the way, there is a branch. Always identify your branches. Ethyl. Whenever you have drawn your longest chain, the root, look at what is the branches and look at the functional group. So the functional group is fine. It's bromo. So look at this. In carbon number 3, comma, we have a bromo, and carbon number 5, comma, 5. How many are they now? There are 3 bromo. So you say hyphen tri. 3 means tri-bromo. Are you with me? So it's 3. 3, 5, 5 tri-bromo. And then hyphen in carbon number 4. Hyphen, what do I have? I've got ethyl. And then longest chain is heptane. One word there. I don't have space, but I'll write it as like that. So it's 3, 5, 5 tri-bromo for ethyl. Let's do the other numbering. And I'm moving from what? This way now. So I'll use this way. So it's 1, 2, 3, 4, 5, 6, 7. Let's do it in carbon number 3. So it's 3, 3, and then 5, right? Bracket, hyphen, tri, bromo, and then hyphen. Then now, where is my ethyl? Doesn't matter. It's 4 ethyl, and then what is heptane? Everything will maintain the same. It's only the numbering there. Now the question is which one is which and why. Look at this. 4 and 4 doesn't change anything, so we leave it like that. But there is your change. 3, 5, 5, and 3, 3, 5. Add here. 5 plus 5, 10. 10 plus 3 is 13. Add here. 3 plus 3, 6. 6 plus 5 is 11. Which one is the least numbering? There we go. That becomes the answer. You always want to find the lowest numbering possible. So the answer there becomes this one. Guys, it is my wish that you master these and just be open in playing around this thing, and enjoy it around. Do left to right, do right to left, and see what it plays around. Whatever maintains means it doesn't play any important role. The one that changes, then you start to say, which one gives me the least numbering? So you ask yourself, 3, 5, 5, just add them. The best thing is to add to get the lowest numbering. Alright. Now guys, we've come to the end of our lesson. In our next part of the lesson, we're going to look at another important organic compound, the alcohols, where we also look at the primary, secondary, tertiary, and also the IUPAC naming of alcohols. I will encourage you to grab hold of this coming lesson. Also to say, guys, we have started long. There are lots of videos, more than 10 videos that I've done. If you're not subscribed, it's because you're not interested with your studies. But if you're interested in studies, I will make sure that I subscribe so that I can make sure that I grab everything. Now, remember guys, importantly, share this channel to your friends and your colleagues. We've come to the end of our lesson. Thank you.